Welcome to the Math 1, Unit 4, Lesson 4, Ready, Set, Go homework video. In Math 8, you learned about writing linear equations from a context. Remember that these linear equations are composed of two parts, the rate of change and the starting value. Just like our work in arithmetic sequences and linear functions earlier this year, we can use this information to write our equation in slope-intercept form. The key is to find the values of these two key ideas in the context and correctly use them in our equation. Remember that slope-intercept form is written as y equals mx plus b, where m is the rate of change, which shows us the slope on a graph of the context, and b is our starting value, which shows up as the y-intercept on a graph. Let's do an example. RAC Rental Company charges $50 to rent a car and $15 for every day you keep the car. If you spend $125 on a rental car from RAC, how many days will you keep the car? We will break this down into two parts. First, we'll write an equation to fit the context, and second, we'll use the equation to answer the question. When writing the equation, it is often helpful to look for the numbers that happen repeatedly, since this is our rate of change. In this situation, we're charged $15 every day we keep the car. This is our rate of change. What we owe, due to the daily rate, depends on how many days we keep the car. Since the number of days is unknown, we can represent this part of the cost as 15x. The $50 charge only happens once, so this is our starting value. Using this information, we can write our equation as follows. Y equals 15x plus 50. It is also important to make sure that we know what the variables represent in this equation. Our situation depends on the number of days we keep the car, represented by our x variable. The total cost is our y variable, since it has the sum of $50 initially charged and the daily charges calculated by $15 times x number of days. Now that we have the equation and we know what the variables are, we can use this to answer the question, if we spend $125 on renting a car, how many days will we keep the car? In this statement, we're given the total cost, which is our y variable. We can replace y with the 125 and solve for x. So we have 125 equals 15x plus 50. Subtract 50 from both sides. This gives us 75 equals 15x. Next, divide both sides by 15. When we simplify, we get x equals 5. We've determined that we would have kept the car for 5 days in order to have spent $125. The second part of the Ready section deals with identifying if inequality statements are true or false. Remember that although inequalities are similar to equations, they are not the same. Inequality notation is used to indicate whether the expression on the left is less than, greater than, less than or equal to, or greater than or equal to the expression on the right. To determine if these statements are true or false, it will be helpful to try out or substitute some specific numbers for the variables in the statement. For example, to check this statement, the notation 6 is greater than x means the same as x is less than 6. This could be checked by substituting 2 in for x. The notation 6 is greater than 2 means the same as 2 is less than 6. This is a true statement. We could try a few other numbers to further verify that 6 is greater than x means the same thing as x is less than 6. In the task you did in class today, greater than, you were asked to identify which statement was larger than another based on a given statement. The ideas in this section stem from the Ready section of Unit 4, Lesson 3. In the Set section, we're going to be solving an inequality and looking at the solution set. There are two different ways this Ready, Set, Go looks at a solution set. The first way is to see if the given value is part of the solution set, and the second way is to graph the solution set on the number line. We've addressed the graphing of inequalities previously in the Go section of Unit 4, Lesson 2. Let's do an example. Given the following inequality, 3x plus 7 is greater than or equal to 22, solve the inequality, indicate if a given value of x, in this case x equals 7, is an element of the solution set, and graph the solution set on a number line. Our first step is to solve the inequality. Subtract 7 from both sides, and we get 3x is greater than or equal to 15. Divide both sides by 3, and we're left with x is greater than or equal to 5. To determine if the value of 7 is part of the solution set, we can replace x with 7 and see if our inequality is a true statement. Since 7 is greater than or equal to 5, we know that 7 is part of the solution set. The last part is to graph the solution set on a number line. Our graph will start at 5. It will have a closed circle because the solution set includes 5, and will have an arrow pointed to the right. This indicates that the solution set contains all numbers greater than or equal to 5. Remember that if the solution set only included values that were greater than 5, but not 5 itself, we would have used an open circle at 5, and still the arrow would have pointed to the right. The last few questions in the Set section deal with multi-step inequalities. The main thing to remember is that just like solving equations, the objective is to get all of the terms with x onto the same side of the inequality so that we can solve for the variable. Be sure to check a few values in your solution set to make sure that the original inequality is true, just like we checked the 7 in our previous problem to show that it was really part of the solution set. If the numbers you check do not make the original inequality true, you will need to check your solution process, particularly to see if you need to change the direction of the inequality. Remember that when multiplying or dividing both sides of an inequality by a negative number, we must reverse the inequality sign. In Math 8, you learned about the Pythagorean Theorem, which says that in a right triangle with legs of length A and B and a hypotenuse of length C, a squared plus b squared equals c squared. The Pythagorean theorem is a biconditional statement, which means that if you have a right triangle, you know that a squared plus b squared will always equal c squared. Conversely, if the relationship a squared plus b squared equals c squared is true, then you know you have a right triangle. In the Go section, you will use the Pythagorean theorem to find the missing measure of a side length of a right triangle. It is important to remember that the hypotenuse of the right triangle is always the longest side. Let's do an example. We know that the legs A and B are the shortest sides of a right triangle. In this case, the legs are 6 and 4 units long, and the hypotenuse is x. Remember that it doesn't matter which leg is A or B. Now that we have the values for A, B, and C, we can substitute those values into the Pythagorean theorem and solve for C. First, we will simplify the left side of the equation. 6 squared is 36 and 4 squared is 16, so we have 36 plus 16 equals c squared. 36 plus 16 equals 52, so we have 52 equals c squared. Now we will take the square root of both sides of the equation, and we have c is approximately 7.21. Here is another example. In this case, the legs are x and 4 units long, and the hypotenuse is the square root of 17. Again, we will substitute those values into the Pythagorean theorem for a, b, and c, and solve for c. First, we will simplify both sides of the equation. On the left side of the equation, 4 squared is 16. Remember that taking the square root of a number and squaring the number are inverse operations. So on the right side of the equation, the square root of 17 squared is 17. We now have the equation 16 plus x squared equals 17. We subtract 16 from both sides and are left with x squared equals 1. Finally, we take the square root of both sides, and we have x equals 1.